Finally, with the platelet activation and the formation of a primary platelet plug, the phospholipid layer of a platelet membrane get exposed on the platelet surface. This provides a crucial binding site for calcium ions and coagulation factor so that coagulation cascade can begin. Now remember, coagulation factors are actually inactive enzyme when circulating in the blood. So after the sequence of platelet adhesion, platelet release reaction and the platelet aggregation at the site of injury, a loose platelet plug is formed. This initial plug is called the primary hemostatic plug or simply the primary platelet plug. But how do we convert this loose temporary plug into a strong tight plug? Well, imagine depositing a large number of fibrin strands around this primary plug and forming a tight fibrin mesh. This makes the plug more secure, and this stabilized plug is now called the secondary hemostatic plug or secondary platelet plug. We can also call this plug plus fibrin network a thrombus. Think of it like this. Fibrin act like a cement while platelets are the bricks. And with the help of fibrinonectin, which is released from alpha granules in the platelets, this plug is firmly attached to the site of injury. But you may ask, where does this fibrin comes from? Fibrin is produced when fibrinogen, a soluble plasma protein, is converted into the fibrin strand in the presence of thrombin. In fact, the whole coagulation process is simply about making the fibrin strand. So, let's define it properly. Coagulation is the process in which soluble fibrinogen is converted into the insoluble fibrin strands. That's it. That's the coagulation.